is Treehouse Village's second webinar on next gen housing. So today we're coming together to talk a little bit more about what it looks like at Treehouse to take an active role in energy efficiency with passive house. I'm going to share a little presentation to start with and give you a little bit of an overview of Treehouse Village. Okay, we'll start with a little overview of Treehouse Village, and then I'm going to introduce some of the other Treehouse villagers that are joining us today and dive into what passive house is going to look like at Atlantic Canada's first co-housing community. So for those of you that are new to co-housing, I'll offer two different co-housing definitions. One can describe co-housing as a form of intentional community where both the physical architecture, the buildings, the built environment, support the social architecture. And that in our minds is this healthy, vibrant neighborhood community. Another co-houser describes it as a small, safe, old-fashioned neighborhood of modern, energy-saving homes where children can play safely, adults can work things out together, elders have neighbors who care, and where we all work and play together. For Treehouse Village, we have a vision that we're creating a joyful, environmentally responsible, healthy, multi-age community in Bridgewater, Nova Scotia, Canada. The development of the co-housing community and all of our group decisions are based around and guided by three core values. So we share a value of our planet, and for us that means living lightly on the earth. A core value around our neighbors, and that's building and living in healthy, comfortable homes, and sharing resources and joy and being welcoming to all. Treehouse Village will be built on the ancestral and unceded territory of the Mi'kmaq people. So we are grateful to be on this land and building here, and we will live in peace and look for means of reconciliation as a community. Also known, the Treehouse Village will be located in the town of Bridgewater, Nova Scotia. So that is a bustling and progressive little town of about 9,000 people. We're about an hour from Halifax, which would be Nova Scotia's largest city. And Bridgewater is surrounded by, within half an hour drive to beautiful beaches, Acadian forests, some UNESCO World Heritage Sites. And the town itself has all of your major amenities, and Treehouse is within walking distance to most of those amenities, whether it be the farmers market or schools or community rec centers. So to zoom right into our site, Treehouse will be built on a 15-acre piece of property, and it's a mostly forested property. And you'll see on one edge of the entire property is the Centennial Trail, which is a multi-use active transportation trail. So a couple key features to our design that reflects this community-based design is that all of our homes, there'll be 30 homes in total, are clustered together. So we're only disrupting a portion of the property, and the most of the property will be left for forest play. All will remain forested. So there's 30 homes built in these 4 buildings. And then in addition to our private homes is the common house. And that'll be 4,000 square feet of additional shared spaces. It's kind of an extension of your living room. So there'll be shared spaces to make food in the kitchen and a large dining area for shared meals. There'll be guest rooms and workout spaces, play spaces, and then this under 1,000 square feet workshop in a separate building for all of the workshop type fun. To zoom in a little bit closer, so we'll have a nature playground on site. There'll be lots of room for growing food, and as I said, most of the site will be left forested, so there will be trails on site too. All of our homes are being built to ultra energy efficient standard, and that's today's passive house, and that's what we're going to chat a lot more about today. So I'll leave it at that for now. And a couple other things. So there's a brief overview of Treehouse to begin with. If you have any questions, I'll invite you to use the Q&A box at the bottom of your screen. You can type in the questions there at any time. Anne is in the background and she'll be answering some of those questions. And if we don't answer it in a chat, then we'll leave it to the end of today's session and answer them together verbally. And before I pass it over to dive in and introduce some of the other Treehouse villagers on our panel today, there's a couple things to note about Treehouse Village that I haven't got to already, and that is that one of our core values, our guiding principles, is that we're a multi-generational community. So we have reserved half of our homes for some older folk and half for younger homeowners or those with children at home. So right now we're really excited to say that we are 70% sold out. And so of the 9 homes that are remaining, those have been designated for our younger homeowners or those with children at home. Our co-housing community will be incorporated as a condominium once the construction is complete. And that is scheduled to be next year already, by the end of 2020, at the end of 2022, end of next year, we will be moving into our new homes. And to note that the target sale prices for our homes are $300,000 to $500,000. That's including HST. And note that we currently have a pre-sales promotion on until the end of May 31st, end of May. And I'll push forward. So if folks are already interested on how to get involved, I encourage you to get to our website and schedule our virtual viewing here on the website, but I can speak more to that at the end of our session. So that is a very brief overview of what Treehouse Village, part of what Treehouse Village includes. So I'm happy now to introduce some of my future neighbors that we have on the panel today. So first, I'd like to introduce you to Andrew, and I'll allow him to share a little bit.
Okay, thank you very much, Emma. That was a great introduction. So my name is Andrew Harvey. My background is that I trained as a mechanical engineer. I've got an iron ring. I have spent most of my career, though, doing more on the training side of things. I started out with an authorized AutoCAD training center, where I was an employee, became a manager of it after a while. From there, went on to an interesting little startup in Halifax, where I was senior programmer and database administrator, and currently working in technical writing and training for a very, very interesting company in Bedford, Nova Scotia, designing control systems and really good, interesting software. So that's my professional background. I'm not retired, and I do get a little bit owlish when people say, "What, you're not retired?" Okay, yeah, gray, but anyway, still lots of room ahead for interesting exploration of technology, which is kind of part of what drew me to Treehouse, was that it's all well and good to be stuck at home here in the year of COVID and doing interesting things online or in my workshop. The idea of sharing a community with people who are also keen on technology, which quite a few of them are, and getting up on a Saturday morning for an espresso and having an espresso fueled design session where we're talking about, all right, what are we going to build next? That's really exciting to me. So anyway, that's a bit about me, and I will turn the mic over to whoever is introduced next.
Great, thank you, Andrew, and welcome. And I'll pass the mic over to Wayne next.
Hello. Thanks everyone for coming, and thanks for the intro. My name is Wayne Grosko, and I am a member of Treehouse Village and super excited to be moving there when it gets built, and very interested in the passive house element of it, which we're going to be talking about today. And partly that relates to the work that I do. I do applied research on sustainable energy, so energy efficiency, renewable energy. So the sustainability of our energy systems is very key, core to what I do. Currently with the Nova Scotia Community College, running the Applied Energy Research Lab. And, you know, aside from the fact that it's super energy efficient, what really drew myself and my family to joining Treehouse Village and being very excited to move there is that we have a now 6-month-old daughter, and we are totally so looking forward to her playing with all the other children in the community and meeting lots of other adults. So that's a big part of our interest as well. So I'll turn it over at that. Thank you.
Welcome, Wayne. And last but not least, I'll introduce Leon, or pass it over to Leon to introduce himself.
Thanks, Emma, and hi, everyone. My name is Leon Devries, and I live in Bridgewater. I've been here for about 13 years, and I have the great pleasure of working for the town of Bridgewater as a sustainability planner for this community. So sustainability and, you know, environmental values and doing community-based development work is something that's really a big passion of mine. My wife, Kate, and I, and our 7-year-old son, we really wanted to have a place to live that reflected our values. And so we were one of the founding families of Treehouse Village. I'm also an immigrant to Canada, so I have a bit of the sort of the newcomer story. I'm from Holland originally. And, you know, it's always struck me that, you know, and I might speak a little bit more about this later, but it's just always struck me that sometimes people don't have the housing options that they need in order to be healthy and safe and be able to live lightly on the earth. And that's one of the reasons that, you know, working on Treehouse Village has been a really big passion for me and my family. And, you know, it's really a strong part of my vision that sustainable housing is something that's accessible to all, you know, all members of my community. And so, yeah, we are living in a world where energy poverty is a real thing. And so how can we create better housing systems for both people who need it, but just all members of our community, and so that we can all contribute to a more sustainable way to live on this planet. Yeah, it's a great pleasure to be able to be part of a project that's bringing you know, one of the most ambitious passive house designed communities here to Nova Scotia. Thanks, Emma.
Great, thank you, Leon. So for my family and I were new to co-housing when we first heard about Treehouse, and it was the passive house design, the energy efficiency, the ultra energy efficiency of this project that piqued our interest originally. It's not something that we thought we could do on our own, or maybe we couldn't do it on our own, but now that we are pooling our resources with 29 other households, building a new passive solar or passive house home is now a reality for us. So I'm going to pass it back over to Andrew to dive in and explain what exactly passive house is going to look like, or is already starting to look like at Treehouse Village.
Okay, thank you, Emma. And I am just sharing my screen here and presenting. All right, can I get a feedback? Is that working?
Looks good.
Well, good, thank you. All right, so what we're doing, we're building to passive house standards using the FIES particular standard, which is Passive House Institute US. There is a one based in Europe as well. We went with the closer one. It aligns better with how things are in Canada and Northern US. So that's the standard that we're building to. And it's all about what you see there, comfort, quality, etc. Stole that directly from the FIES website. So what are we doing? How are we building this to the standard? Well, certainly lots of insulation. Airflow, super important. You need to have lots of good air in order to meet this standard. And clean energy matters as well. So for the energy that you use, they care about how do you generate that. Oh, there we go. Okay, yeah, there is a few more details. So let's start with the first one, insulation, because that's how you stay warm. And we begin below the slab. Now, some of our buildings, 2 of them on the uphill, will be slab on grade. The 2 downhill will have basements under, 1 for parking, 1 for general storage. But below those slabs and below the floors that are above basements, we're going to put in R40 of insulation there. The code would be about R10. Don't hold me to that. I just did a quick look up on Google this morning. But from what I could find, yeah. And I've been on these houses and they do have cold floors. We're not going to have cold feet. So we are going to keep our toes warm. And we're also going to make sure that the footings are insulated on the outside just to avoid thermal bridging, which is a super important concept and one where a lot of code-built houses really fall down. Floors above, the roofs. Okay, we're building those to R92. Yeah, code would be maybe 40 these days, 30, 40, 92. We are planning to keep the heat on the inside. Walls, those have been a bit tricky. So where we began with the wall design, we had a double stack of 2x6. They were staggered, so we did not have the thermal bridging. And that was going to be 2 different layers of insulation there, bit of modeling to make sure that the wasn't going to be any condensation within the walls. Actually, the modeling caught a mistake and we managed to fix that. However, this is the 2nd year of the pandemic, and you all know what's going on with the building industry. We don't own enough Bitcoin in order to afford spruce studs. So we had to switch over to a current design, which is Fox Blocks ICF with 3 energy sticks. You might be wondering, what did he just say? All right. What that's all about is ICF means insulating concrete forms. And I've got a little image here. You can see a wall going up built of them. And there's a detail here, 2 layers of insulation, the core, filled with reinforcing, that's both plastic and metal. So there is super strong structure. That gets filled up with concrete. The energy stick that I mentioned is extra layers of insulation that you put inside that. Why inside, not outside? Well, this stuff you've got on the inside to hold it all together, you want to make sure that those reach right out to the outer level of the insulation, partly to hold it all together, and partly so you've got something to hang your walls on, both inside and outside, so that you've got, something that looks like not just foam. Anyway, the energy sticks go on the inside. They all go on the outer side of the concrete, which means you've also got thermal mass relatively close to the living space. So the idea is going to be that you've got a little bit of insulation, then you hit the concrete. Over time, that will warm up. And that's going to give you a really good buffer on temperature so that you're not going to get big swings. On the outside of that, we've got lots of insulation. So total R value, 48. The picture over here of that really nice looking house, no, that is not what our houses are going to look like. I threw that in there to illustrate that going to this form of construction does not mean you can't have a really nice looking house. We're going to have great houses. They don't have to look like some sort of institutional, Soviet era apartment blocks. They can be pretty good. All right, so that's going to be the walls. Windows, super important detail. Triple glazed, FIES certified. We're going with casements. We've had a few people saying, no, we'd rather have double hung. But the trouble with double hung is really, it's incredibly difficult to get them and keep them in a state where you don't have air leakage at that junction between the two pieces of glass, or the two parts of the window that slide past each other. By going with casement, and we are actually exploring tilt and turn for some of the windows, just an exploration right now. But that gives you a solid, effective seal so that you don't get that air leakage around the window. We're also going to make really, really sure that we don't have thermal bridging around the edges of the windows or anywhere at all close to the windows. Also minimize the air leaks there, which, I don't know, have you ever noticed on a cold winter day, when you've got condensation forming on your windows, it always forms not across the whole window evenly. It starts out at that bottom edge, goes up the sides, it's coming in from the edges. That's happening because the edge of your window is touching something cold. And the coldness is hitting the glass, cooling it first, and that's where you're starting to get your condensation. So the condensation is telling you you've got a flaw in your design. We're avoiding that. We're making sure we don't have that thermal bridging. We're making sure we don't have those air leaks. And continuing on about those air leaks. So absolutely, you need to avoid them. And as my slide says, it's not just the cold air. The worst thing about the air leaks is the condensation that they cause. And you'd see that if you crack open a window, or if you've got a double hung window, maybe you've got a door to the outside and it's got one of those sliding windows in it. Okay, you notice right above the junction in the middle of the window, how it's always kind of turns a little dark there. That's your mold growing because you've got an air leakage coming in, hitting the lovely moist air in your home, causes condensation, causes mold, causes rot. We need to avoid that. So what we're going to do is, all right, great construction should avoid most of that just off the bat. But construction, there's always going to be something goes a little wrong, somebody's not careful enough. So once all the structure is built, and before we put in any of the finish work, we're going to bring in aero barrier, which is essentially what you do is you depressurize the living space. Sorry, not depressurize, you pressurize it. So you get super high pressure inside that, squeezing out through every single possible crack. And then you spray in the aero barrier compound, which this is not the technical term for it, the magic goop, which is basically it's suspended in the air, which is heading out through all the cracks. This stuff lands on the edges of those cracks, it sticks, it builds up, and just like your high cholesterol diet, clogs the flow and stops the flow. So that should take care of all of the leakage, and therefore no condensation, no air leaks, no mold, no rot. All right, what about breathing? Everyone says, well, wait a second, this is why we'll have our 100-year-old homes. They breathe. Yes, they do. But you throw in a vapor barrier, throw in a few other things. 100-year-old homes are good, but you need a lot of heat to keep them warm. Try to keep them warm with modern standards, and all of a sudden you've got those condensation problems. So what we're doing instead is bringing in energy recovery ventilators, really good ones. FIES certified heat recovery, energy, not heat, energy recovery ventilators. Those will have filters, so you've got nice clean air. They will capture most of your heat, but they will get rid of the stale air. They'll get rid of your smelly sock odor. They will get rid of your cooking odors. And when you've got a shower or you're boiling up some pasta, flip a little switch, dumps out the super moist air, keeps the inside nice and fresh. The other thing about these is that they will contain our primary heat source. There will be simply a heating unit inside those to give us all the heat we need. And no, it's not going to be very big. In fact, more about that. So we did some analysis on this. So these small heating coils just in the energy recovery ventilators we did some calculations and we found that some of the units, not all of the units, but some would need a bit more heat on your coldest winter days. 700 watts. I mean, seriously, that's a 1500 watt heater that I've got a picture of there, right? So, but yeah, we need those extra 700 watts. What are we going to do? Well, we could have said, all right, go buy yourself one of those things. Cheap solution, but can you do that really? Hey, you're going to have to go buy a ceramic heater in order to stay warm. No. Put in baseboard heating. Oh, those are horrible. No. We decided in-floor heat for the bathrooms and the entryways. All right, come on. Who doesn't want in-floor heat in their bathroom? So that will cover the energy deficit on the cold days, gives you that extra little bit. And sure, you just turn down the heat at the ERV if you'd rather go with heat coming from the floor. So you keep that balanced. But that gives us a really cozy solution. And you don't have to tell people, no, you're going to have one ceramic block heater. Cooling. The design will include the ability to install that if required. We're betting that nobody's going to require it, but just in case we're wrong, we are anticipating global warming might not stop immediately. So just in case, the option will be there. It will absolutely be possible to retrofit and add in your cooling. But let's wait and see. We're not that far from the Atlantic Ocean. Should be able to stay cool. Plus, that's another advantage of our FIES design. All of that insulation keeps the cold out. Sorry, the heat. It keeps the heat out. All right, one last bit. Clean energy matters when you're building a FIES design, because they consider that when they're doing the modeling. And if you're getting your energy from a dirty source like coal, Nova Scotia, that costs you points. So we are going to install solar. And we're still working on the design, but the short version of it is, even though that we're on a north slope, and even though we're not oriented perfectly to the south, we're still going to be able, as far as physical limitations are, to sort of max out the energy, the bus bars, and kind of stop there. So the solar will not supply all of our energy, but we do plan to use net metering. So hoping that over the course of a year, it averages out. And that bit about points that was emphasized. Well, this comes back to why we're doing FIES. There's a lot of modeling upfront to ensure the design meets specifications, so we don't guess. We make sure that the specifications are right. That saved us a lot of money on the installation of the heating, because otherwise our engineer was going to have to go with code minimum, which would have required the installation of much more expensive units. So by going with FIES, we avoided that cost. And it also requires testing to make sure that it was done right. There's no hoping that they got it right. It'll be tested, flaws will be fixed, and it will be right. And the result are going to be healthy, cozy homes that these should last 100 years easily and just keep on going. All right, I'm sorry if I went a smidge over time with that, but over to anyone who has questions. I'll let you take it back, Emma.
Great, thank you, Andrew. Lots of information. So if you have any quick questions, you can drop them in the Q&A box, and if there's longer answers, we'll come back to them in a few more minutes. So I want to pass it back. I have a question for Leon. So Leon, like you mentioned, his family is the founders of Treehouse Village, and you started this project with this seeking out housing that reflected your values. So how do you see Treehouse Village and Passive House being this next generation of housing?
Yeah, it's tough. And Nova Scotia has a really kind of limited options for housing, and new homes are typically built, generally to code minimum, and you know, there's an industry here that's not used to building highly energy efficient homes. So if your family really values living lightly on the earth, really minimizing your energy costs, or even being, you know, net zero, where you're producing as much energy as you're using, like, how do you do that? How do you find that kind of housing in you know, in this area? And for us, we couldn't find it. It wasn't there on the market. And so, you know, you've generally got kind of, you know, two options. Well, either you can just not care about that, or you can, you know, go through the expense and effort of building a home from scratch by yourself with your family. And that means navigating all of these technical requirements, you know, having these professionals work just for you to do designs and things like that, or kind of DIYing it and doing it yourself. And, you know, those things just were neither affordable for us or options. And so I really think that, you know, what we're doing with Treehouse is it's like we're relying on collective effort, right? We've now got 30 households that are coming together and building top-notch housing together, and not for the kind of astronomical rates that you would have to pay if you were just doing this yourself as a single kind of family or individual. We're relying on that economy of scale that comes with, you know, having one architect come in and do 30 homes, and bringing in one passive house specialist and doing 30 homes, right? And then also the economy of scale and buying the equipment in bulk. That's really how we're saving and making this possible. And you know, I think that this is really important too for the industry in Nova Scotia. You know, we already know that you know, a whole bunch of suppliers and builders and tradespeople are really interested in working with Treehouse because they know that this is the future. You know, energy efficiency in the Canadian Building Code is ratcheting up over the next 10, 15 years. Net zero construction is going to become mandated for new construction, you know, in the 2030s. And so the writing's on the wall, and yet, you know, the industry isn't really ready to do this yet. There's still a real gap in knowledge. And so I think what's exciting is that Treehouse is a real opportunity for us to build knowledge in Nova Scotia, to demonstrate, you know, you can feel and see this building that's been built. These people are living here, it's comfortable. You know, we were able to do it for just a hair over the cost of regular, you know, market rate housing, and if not for less, actually, given all of the features that we're building into this. And it's just a really exciting way to contribute to like this next generation of housing that's coming to this province, and showing that it's possible, and that people, like ordinary families like ours, have the ability to participate in this and to have a sense of control over their what their home is, and how they're living out their environmental values, and really controlling those energy costs over the long term. Making quality housing accessible to people is a really big passion of mine, and something that we're really trying to make happen with this project. So hopefully others will follow in these footsteps, and we'll be able to find ways to do it for even less, you know, or you know, even more on a larger scale. So yeah, I think it's about being part of that transition in housing that's coming.
Very exciting. And to Wayne, so what does that look like? So this next generation of housing that you're a part of, what will that look like and feel like for your family?
Yeah, thank you. And thanks to Andrew and Leon. And particularly, I want to touch on something that Leon said about the value of being able to show people how this works, that a passive house works, it's fantastic, and that it actually, you know, it can be done. And I'm going to speak a little bit about my own experience, because in the course of my research work, I did have the great privilege to go and spend some time in a few different passive houses. So I've seen them on the ground and can speak a bit from experience about that. And I'm going to show folks. I'm going to attempt to share a screen here. Hopefully it'll work. So folks see a picture of a nice house there? All right. So this is billed as New Brunswick's most energy efficient home. And it is built to Passive House standard. It's near Fredericton. And this, we might at some point share the link to this article. It's an eco home. It's a very good description of this house, but I'll say a few words about it. A colleague of mine was the Passive House designer on it. So I got the chance to tour it during construction and to go hang out in it in the wintertime and on a sunny summer hot day as well. And this is a little bit different from Treehouse Village because it is a single family detached home. But in some senses, Treehouse Village is a little easier to meet the Passive House standard because all the houses are together, so they can share some common walls and not need as many exterior walls. So if they can do it with this house in Fredericton, which is a colder climate than Bridgewater, we can definitely do it. So this is a magnificent house, and it's about 1,600 square feet. It's built to the Passive House standard. And I'll just start right at the top line. $77 per year is the heating bill for this home in New Brunswick, in the Fredericton climate, which is quite a bit colder than the Bridgewater climate. $77 per year. Just for comparison, if this house was built to the normal code, projections are that it would cost about $2,200 per year to heat it. So that's just the heating, not the rest of the energy. Just an incredible amount of reduction in the heating bill. So that's a wonderful benefit. But what is it really like to be in this house? Frankly, I'll say it's amazing. So I was there on a cold February winter day, and I'm just going to scroll down a bit to where there's some pictures. So you're hanging out in this living room, and it's absolutely cozy. Like, it's so sheltered. The walls are really thick, which means that the windowsills end up really thick. As you picture this family's child, who's not pictured in the photo at the moment, but they were sitting on this windowsill on a cold day in February in their pajamas reading a book. And like, they were totally comfortable. And you think about doing that in a house that is not so well insulated, and it would be chilly, but there's nothing like that in here. There's no drafts, there's no cold spots. Everywhere you go in the house is comfortable, which is just it's just a wonderful, place to be in. It just feels very, very sheltered. They give a few examples, but I won't go through the details of how it was done because Andrew really described that well. But lots of insulation and really good windows is the main point. There you see the insulation going underground. I think, and then blowing in the insulation. And then at the bottom of the article, it explains the different costs. One of the benefits of talking about this house is that it was built a few years ago. So they wired it up with sensors so that they could measure all the performance. And essentially it did great. And you see their annual heating costs, $76.82 per year, compared with $2,217 if you built the same house to the normal code. So I'm gonna keep it brief because everyone else has really covered really the details about Passive House. But just to say that it's they're beautiful, beautiful homes to live in. Totally. And just zooming out to the big picture for a second, where we're approaching Earth Day and thinking about how we live lightly on the earth. This house and the Treehouse Village homes, with good maintenance, there's no reason to think that they couldn't be operating for 50 or 100 years. If you think about the longevity of that. This home, when you think about climate change and greenhouse gas emissions, it saves about 11 tons per year in greenhouse gas emissions by having such a much lower heating energy. And that's would be on the Nova Scotia energy system if it was built in Nova Scotia like we are. So 11 tons per year. Over 50 years, it's 500 tons. It's really large, the amount of savings that result from building in this way. So I'll leave it at that. And if folks have questions about like being in a passive house, I've been in a few of them, so I can speak to that. Thank you. Back to Emma.
Great. Thank you, Wayne.
I will stop sharing.
So just looking over to our question and answers, we'll have another 5 minutes together to get any of your questions answered. It seems like we've had a few in the chat box already that have already been answered. Is there any other of our participants today that would like to know more about what Passive House is going to look like at Treehouse? So Allison has just typed in, wondering with all these tight sealed windows, are we going to be able to open windows when you're living in a passive house? I'll pass to Andrew.
Oh, and I just realized I was not muted. Yes, you are. Those are going to be casement or possibly tilt and turn windows, so for sure. And that's part of how we'll be able to stay cool in the summertime, is open up your windows at night, let in all that lovely cool air, and close them up during the day.
And I'll just very briefly add, the windows certainly will be openable. You can open them, but in the middle of winter, it's an operational question. If you leave them closed as much as you're comfortable doing so, and rely on the heat recovery ventilator to give you the fresh air, you save more energy that way. So it is actually an operational choice, but you have that choice because the windows, the windows are able to be opened.
If you have any more questions, feel free to drop them in the Q&A box. It's something to hear about this project is very exciting as I sit here with my warm moccasins on my feet and seeing the condensation on my current home windows, and to hear what, coming together as this co-housing project, what we are able to build when we collaborate. So we have another question from Mary. I wonder if you have a feel on how much more Passive House takes to build compared to, we made a couple comparisons to building to code. Would one of our panelists like to answer that?
I suspect Andrew may have the figures on what's projected for Treehouse Village, but what I will say is about the example house that I gave is that they measured they estimated a 10%, in their case, higher cost of construction. So that home, and it was built a few years ago, so certain material prices have increased. But that home was projected to cost $300,000 in construction cost if they built it to normal code. And in the end, it cost $330,000 to build it. So it was a 10% extra. And what I find interesting about that particular one is it was financed on, I think, a 20 or 25-year mortgage. So that construction. So that difference in price was amortized over that period of the mortgage. And the result was, of course, the mortgage payment was a little higher because upfront construction cost was a little higher. But in their case, the energy cost was so much lower that they actually were cash flow positive from the start. From the first month, they were paying less than if they'd built a code built house, just because of being able to amortize that extra construction cost over a 20 or 25-year mortgage. So that, they were very excited. We're living in this fantastic house, and it's actually costing us a little less per month than if we had built a slightly less fantastic house. But I actually not the person who has the figures for what's comparison for Treehouse Village, and I'm not certain if we know what it would have cost to build it to code because we're not building it to code. But I don't know, Andrew, is there more to say on that?
It's a tricky one to answer because it's a very unique sort of project that was never going to be code based. But I'll toss in one. What you just said was incredibly important. It was the savings on the energy offsetting the extra cost. Was talking to the architects just on Friday, and they passed along a really interesting bit of information. For a lot of their work that's being done within Halifax, they were telling me that houses that they would have designed that would have cost between $300,000 and $400,000 to build just a couple of years ago are now $1 million houses. And that's just how things have changed. But because we've got our design locked in and we've got a construction manager who's incredibly good at being proactive and locking in the materials and locking in the supplies, our prices are not going up the same way they are if you were trying to build your own house from scratch starting right now. So we're kind of, it seemed more expensive a year ago, and now compared to what's happening within Halifax, it's starting to seem dirt cheap. So just a comparison of the industry and how things are going.
There is, I'll just jump in to say there's a question there that I would really love to answer. So I'll jump into it. And that is, do the buildings have to be angled in a specific way, RE sun position? So that question is from Allison. That's a really interesting design question. So the passive house standard or principle can be used to design a home that is oriented in any direction to the south, which is one of the neat things about it. But as people are probably aware, in where we are in the Northern Hemisphere, if you face the building towards the south and put more of the windows on the south side, then in winter, you're going to get more heat gain from the sun, and therefore you won't need to expend as much heat. So that's another, we call that the passive solar design, which kind of has the same word passive in it. The way the passive house standard works is, if you have a house that is ideally oriented like that, so it has a side facing to the south and you design lots of windows into that side, you might get away with a little less insulation, because it's basically a modeling process where you reiterate the design with more or less insulation until you meet the goal, where the goal is a certain amount, right? It's less than 15 kilowatt hours of energy used per heating per year, per square meter. So you're just trying to meet this goal. And if you happen to have a good site where you can face the building to the south, you're going to be able to meet that goal for less, let's say. But if you have a really difficult site that doesn't have a lot of sun access, then you need to put in more insulation until you do meet the goal. So short answer is, it can be done in any orientation, but it's easier to do if you have south orientation in the Northern Hemisphere.
Thank you, Wayne. I was just looking at the time, and although I'm sure there may be a couple more questions, I would just want to take a minute to thank all of our panelists and everyone that was joining in for today's webinar on Next Gen Housing. You can keep an eye out for another one. If today's conversation piqued your interest and maybe you have some more questions, I encourage you to follow up, reach out to our members, and the way to do that is to connect with us on our website at treehousevillage.ca. And if you're looking to dive right into more details, you can go ahead and schedule a virtual viewing and give you a virtual tour with more detail on what these passive homes will look like at Treehouse Village. So thank you to Andrew and Wayne and Leon, and look forward to hearing from our participants if you have any further questions.